All right, so welcome everyone. So today we will have a talk from Joshua Cornejo on WAL-E wants to do what? Future authorization challenges with agents. And this basically will be about access control mechanisms and where Joshua will look into or explain why the traditional access control mechanisms, like we have role-based, policy-based, attribute-based, and so on, they don't work. But when we have modern agents which are more fragmented with different personas, so to say, then these kind of access control mechanisms need to be told, and the access should be granted actually at the moment of the task happening. And this way we can ensure security and compliance. And with this, we can transition to Joshua. So Joshua, you can take over and
So
present.
basically, I think the first point is to start defining who is Wally. And here at the top of my slide, you have the human identities, but then you can see that there's all sort of things that can be considered non-human identities. This is a taxonomy created by the Non-Human Institute. And basically you have on one side API keys, tokens, secrets, certificates, service accounts, technical accounts, administrator accounts, and system accounts. And they live in all sorts of different components. It could be hardware, it could be in a mobile device, it could be in a server, it could be inside your laptop, your desktop, in the Internet of Things, in machinery, specialized machinery, which you could consider a computer or a server, but let's just separate them into different category. And basically on any tech equipment that is used in any industry. And then you have also the fact that they live in the software. They live in applications, databases, services, scripts, APIs or microservices, operating systems, virtual machines, containers. And more recently, they have become part of the robotic process automation, where you could still think of a process in a traditional way, and even more recent into what is considered now the realm of AI, large language models, AI agents, and chatbots. For me, for some reason this thing sometimes doesn't display everything. You can think about it in a very simplistic way. You have something like Siri running inside your phone, and if you have seen the news, Apple says, well, if Siri cannot do what you need it to do, it will go and reach out at OpenAI and make the call. The question becomes is where is actually Wally running? If you're asking it to do something now, it might be that it's done all done by Siri or is done by OpenAI at the time that you're asking for. But you can think about it in the future, making scheduled calls that you say, I want you to do something in 4 hours, and maybe it's not done on your phone anymore. It's done by the OpenAI. So those are the new problems that are emerging with um, with agents now. The agent not only doesn't run where you think it should be running or it has traditionally running, it might not even run inside the same set of calls that triggered that agent. So you can think about it as well from a very discrete point of view. You have the humans, which are the more discrete, and then you start moving towards the right to say, well, you have a computer process that could be considered an account, but now you also start moving into business processes. So the fulfillment of a business process might require different personas to be executing something from beginning to end. Then you move into local agents, and finally you move all the way to the right into what is called blended swarms or cloud agents. So now the agents could be they're no longer what you could consider a traditional computer process. They don't have necessarily the same run at the same time, run only for you. It could be something that in the case of ChatGPT, it could be the same process fulfilling the request of everyone in the organization. Okay. So you can see that the problem is large. On the one side, you have extreme amount of devices and pieces of software that need accounts. Then you have the accounts blending from very discrete to very vague. And on top of that, you have the problem of the general digital rights management. So in technology today, the vast majority of access controls are done for developers by developers. So if a user in a product organization has a request to do something, that usually is just transcribed into a set of scripts, OPA in Rego, or whatever proprietary language the organization has. But the reality is that as we move further and further, a lot of these requirements are becoming more the realm or the scope of the product owner. So you can start thinking about your rights, your policies as something that has to be more controlled. So each component has each person will have a set of responsibilities. It has to be traceable. So a file might have worked before, but as your policies get more and more complicated, you need to start to be able to trace the policy or policies across your life cycle. It has to be connected as well. So the semantics of the elements that you are trying to define, they need to be connected. What means something for you. The example that I usually put is if you have a file-based diff and you have that a policy can only run in Germany, Spain, and France, and a new version of that policy says France, Germany, Spain, the diff will look at it as they are two different things just because the strings are different, even though the attributes are the same, they're just in a different order. So you need to start thinking in a more in a more graph base about the definition of your policies all the way down to the attributes. It has to be visual. Obviously, when you have something that allows you to just control the virtual machine inside a Kubernetes instance, it might be very easy. But when you are trying to intertwine really complex data products over complex infrastructure to provide complex services, now you need to start making it more visible for the user so that they can operate and work better. It has to be standardized, so ideally you want to work on something that it's consistent across the organizations. So you don't want to start creating new languages or inventing new languages um, in order to fulfill your what you think are your requirements. There's a need for it to be standardized. It has to be also extendable, so you cannot define all of your use cases and all of the type of policies that you're gonna create uh, from the beginning. So you have to start leveraging things like, again, ontologies and RDF or JSON linked in order to create something that is fundamentally um, good as a start, but then you can create whatever set of components you need to be using in the future. And finally, obviously meaningful. So you have to start thinking that your ontologies have to be shared across, and that's the same thing. If you're talking about the day of the week, it means the same thing across all the different users that you have in your organization, and even if you have some cross-organization type of engagement. Historically, you can think that in the beginning, when you had mainframes, authentication, authorization, and process and data all lived in the same component. So you didn't have um, any separation of concerns. And as we go to today, in today's world, you have the outer ring of authentication. It could be a federation that says, you're presented with a page that says login with Google, login with LinkedIn, login with your email address. And at the bottom, you have also the applications have evolved to call different sets of APIs, be in the same service or be local to your application inside your mobile device or your laptop, or they could go straight to a database that is local or remote, or they can go to an API that goes to a database. Um, but authorization has somehow still remained really tightly connected to the creator of the application. So the creator of the application will, up to a certain extent, determine what they want to do. with the ones the user has logged in, as opposed to relying on a third party to do that service the same way as they call an API, or the same way that they allow Google to be the one that authenticates the user. Um, you can see some of the pictures that I portray are when you have your authentication from multiple different accounts, and you have an ecosystem of authorization providers that allow you to connect and create applications in whatever combination you want. So your application becomes just a path that says the authentication of your user is in here, and this authentication has a way of connecting to this authorization, and this authorization allows you to go to all these four different components. Okay. The proposal that I am making in the work that I am doing, I work with ODRL, which is the Open Digital Rights Language from the W3C. I am saying that in order to make it distributed, scalable, well, first of all, you work with the centralized IDs in the authorization layer, and you get your account in your authentication layer to have the claims, and these claims are to authorization endpoints. So you basically can then do what the previous slide says, go and create distributed applications that allow you to work with whatever the scope of each of these individual authorization components are. So you can connect to your APIs or your databases or whatever other components you have in your solution. Uh, at the moment, the state of the world is, again, quite fragmented, although it has started to collapse into at least two things. Um, you have Rego, and you have OpenFGA, and you have uh, standards like Solid that have implemented their own WAC ACP, and you have ODRL that comes from a media specification. But fortunately, everyone is sort of converging to making calls that are actor is trying to do an action over an asset. You can think as more complicated or as complicated as you want, but in the best case scenario, you're looking at three URIs in here that are identifying what is the actor's ID, what is the action that they are trying to execute, and the over which asset. Uh, in a tangible way, the way I'm trying to address the delegation is by proposing that in the authorization layer, where you have your policy decision point, a management task can say that a user, which is this user here, can have a delegate, which is going to be an ID of an agent, and this ID can execute a set of actions up to a certain number of times and up to an expiry point. So you can basically, obviously, this is a role that can happen individually. It can happen at the beginning of the day. It can happen at the beginning of the engagement of the agent, or it can happen dynamically inside the application. Um, but basically, this restricts what or narrows down what the agent can do. So the user, when they submit a request, they still use the principle of the user ID, the action, and the resource that they want to target on the policy enforcement point. But the agent now has to say that they are a delegate. So in this way, the agent doesn't need to provide the ID of the user, and the management or the PDP will work out by saying, well, is there a relationship between this delegate ID and this user ID within the amount of times they want to execute this action, and has it not expired? So this sort of solves the problem, because the agents are no longer processes. So you can assume that this ID could be reused later on to do something else, as long as the scope hasn't expired. Oh, actually, I forgot to mention something. I apologize. In here, so obviously, in the requests, you have to send which is the did, or the scope or the context that you want to execute. So when you're coming in here, you always have that as part of the engagement. So this relationship here will be in the context of one context, and the user request and the agent request would also be in that same context, or with that same context in the parameter. So this agent could be associated to other people in other contexts without any clash between where you're trying to enforce a request to the backend. Um, there's other elements that can be implemented. For example, you can have something in an authorization called the phantom pattern, where you can think of it as the device makes a request, and all they get is a token. It could be a JWT, and when they go with a JWT to the policy enforcement point, they submit the token, and the policy decision point tells the policy enforcement point what is that can be or cannot be done. So this further down narrows the ability of the agent to know or to have any security breach. So if you go to back to the beginning of the slides where you have the agent that could be Siri inside your device in here, or it could be OpenAI running in a third-party data center, this obfuscates even further the ability for OpenAI to get into your system, because they no longer even know what is that they are authorized to do, because it's all done by the policy decision point behind the scenes. And that is all of my content. If you have any questions.